I believe in junior high, maybe, they spend a day on this or so. Most people do it, they're like, oh, okay, I can do it, and then it falls out of the side of your head or whatever. I'm going to show you a couple of different tricks. This takes, for some of you, it'll take more time than others, all right? So just be consistent, all right? So first thing we have here is we want to talk about what is a chemical reaction, because that's really what we're going to be talking about today. We're introducing chemical reactions, a process by which one or more substances change to produce one or more different substances. Don't write that down. What does that mean? Not sure. Why write it down? One of the things that I learned when I went to college, I took like intro to bio, wrote everything down that I saw. My hand was ready to fall off at the end of the class. And then I got done and we got to the test and I went to go review my notes and I had no idea what it was saying. It's kind of an issue, isn't it? So make sure, I guess my one life lesson for you here today, oh, I got a couple of them, is to, if you're going to take notes, make sure that they make sense to you. I just got back from a coaching conference in Chicago, and I walked into this one lecture, and that was on a slide. Everybody see what that says? It just said banana vomit. Banana vomit, that's it. No, so I was laughing because people around me, right, see, I learned after my college experience that I'm not going to write that down. I don't know what it means. What does that mean to me? I don't know. But there were like people that would walk in and, banana vomit. Had no idea what it meant. Right? So moral of the story is, if you're going to take notes, make sure that the notes make sense. Right? Oh, you're all sitting in different seats. There we go. Okay. Yes. So it's basically, it's two words that don't go together that are supposed to give you kind of like a feeling, right? Because you're supposed to, I don't know, most people either really don't like bananas or they really don't like vomit, and putting the two together makes you kind of like have this response. And so it was all about the psychology of banana vomit. It was very interesting. But anyways, back to the chemistry. So how do we know? So we've got this definition of a chemical reaction. Basically, one or more things are changing to produce something new. How do we know a chemical reaction has taken place?
The color changes.
Color change, one. Smell.
Temperature.
Temperature, so there's heat given off, there's some sort of energy given off. What do you see?
Nothing. Smell.
We said smell, right?
Bubbles.
Bubbles! Yes. Finding Nemo. Bubbles, bubbles, bubbles. The Ring of Fire?
No.
Shark bait, ooh-ah. Okay, you got all of them, right? So, color change, odor change, bubbles, energy change. The last one, precipitate. You're going to see that next week. Precipitate is when we take two liquids together and we make a solid. What is a chemical equation? You've got 30 chemical equations in front of you. What is that really? It's really telling us the chemical change that's occurring. And it's kind of like a recipe. Anybody know who this guy is? Gordon Ramsay. I love this guy. He's really mean, but he's very real. He'll tell it like it is, right? With a few extra words. So, the reason why I have Gordon Ramsay up here is because when we look at this, it's kind of like a recipe. If you don't follow that recipe, whatever we put in is going to come out, right? If you don't follow the recipe, anybody not follow the recipe? How does that turn out? Let me tell you a story. My wife made me lasagna one time. True story. She made me lasagna. Actually, she makes dinner all the time. And guys, let me just give you a little piece of advice. Whenever your spouse, wife, whoever, makes dinner, it's the best thing you've ever tasted. Mmm, delicious. How was it? Best thing I've ever had. So I get home, and she said, I made lasagna. I was like, yes, I love lasagna. Delicious. Sit down. She had swapped out teaspoons for tablespoons of salt. Yeah, I took a bite, and like my eyes started watering. But you know what I said? Best thing I've ever had, yeah. Right? And then she took a bite, she's like, we gotta throw this away. So it was her conclusion, not mine, all right? So our chemical reaction is the same. It's a recipe, right? Whatever I put in has to come out. I don't just lose stuff in the process. All right, so if I focus on, say, like this carbon here, I can see it over here. Or if I look at the oxygens, what if I only had one oxygen, one O2 here? You see how, well, I need 2 oxygens around the carbon dioxide. What about my water? Where's the oxygen for that? I wouldn't have enough, right? So whatever we put in to the recipe has to come out on the other side. So the way that we balance an equation, the way that we make sure it's the same on both sides, is we add what's called a coefficient. A coefficient are these numbers. You see on your practice sheet there, there's a bunch of lines. That's where we're going to add coefficients to make sure that it's the same on both sides. Our reactants are on the left. They react. And then big shocker over here. Our products are on the right. They're what's produced. Okay. Let's get into it. So I'm going to actually do problems off of your practice sheet here. That what goes in must come out. So number 6 we're going to start with. I'll show you a very basic method of balancing. We're going to start by just counting these up. So I always like to add a little line here that helps me separate our reactants from our products, which is an I can statement. We want you to be able to identify what a reactant is and what a product is. The next thing we want you to be able to do is to be able to balance, which is what we're doing now. So I'm going to just count these up. How many hydrogens do I have? That's an easy one. 2. Okay. How many chlorines? 2. How many hydrogens over here? Just 1. Same thing with the chlorines, right? There's nothing written, so I can assume that they're 1s. Big problem, right? It's not balanced. It's not the same on both sides. How do I fix that? I have to, can I just put a 2 here? There, I made it, I fixed it. The answer is no. I can't change the formula. The only thing I can do, let me just get rid of that, it's bothering me, is I can put a 2 in front of there. I can only mess with the coefficients. I can't change the formula. So now when I put a 2 there, that 2 is going to distribute, if you like math terms, to the H. So now 1 times 2 gives me 2. And now 2 times 1 times 2 for the chlorine gives me 2. We're balanced. 2 hydrogens on this side, 2 hydrogens on that side, 2 chlorines, 2 chlorines. All right? So far so good? Okay. Seesaw method. This is my main method. Okay? Number 15. If you ask me from here on out really how to do these, this is the method that I will usually use. How many of you know what a seesaw is? Or a teeter-totter? Right? If you have younger brothers or siblings, it's like I had a younger brother, and we would do the seesaw thing and see how far I could flip them across the playground. No? You know what these are? It's like that thing that you like sit on, right? And then you do that, and if you jump really hard.
I think
Okay.
we all.
So basically, we're going to start on one side. We're going to bounce back and forth. So when I look at the left side, I've got 1 carbon. I'm just going to start with the carbon. Start by putting a 1 there and try to balance everything based off of that. So I've got 1 carbon here, 1 carbon here. And before I kind of get too crazy here, I want to point out Aaron Rodgers down here. He's got a pro tip for us that we always want to leave the lone elements for last. So whenever you see an element by itself, leave that for last. Whether it's hydrogen or oxygen, those are usually kind of the ones that are alone, but try to leave those for last. I would write that down somewhere either on your yellow sheet or on notes, whatever you've got. I'm going to continue counting here. I've got 4 hydrogens, only 2 here, so I can fix that, not by changing the formula, but by doubling what I have there. 2 times 2 is now going to give me 4. So my hydrogens are good. Now I've got my oxygens. So I have, let me just count here, 2 here, plus 2 times 1, it gives me 2, gives me 4 on that side. And then I have 2 over here. If I multiply that by 2, I got 4 and 4. Now, you don't have to do all this writing. If you could do this in your head, if you can look at this and go 1 carbon, 4 hydrogens, 4 hydrogens, great. I'm good with that. All I'm looking for is the balanced equation. Do we have to write the ones? No. But if you're like me and you like to have every blank filled, then knock yourself out. Okay? You all right? Pro tip number 2. Here's Serena Williams. She says, if you get stuck, double the known coefficients. We're going to need to do that. This is number 8 on that yellow sheet. What do we do if we count up the atoms and you end up with an odd number on one side and an even number on the other? Stuck, we're going to double the known coefficient. So I'm going to put a 1 here. I'm going to try to balance everything off of this. I got 1K. I've got 1K over there. I see 1 Cl, 1 Cl. Life's pretty good. Till I get to the oxygens. I've got 3 oxygens there, right? 1 there. And I've got 2 oxygens there. So now I'm in a little bit of a jam. There's nothing I could really just put there because I, pro tip number 1, left the lone element for last. What could I put there? Some of you might be like, ooh, math, I got it. Can I put a decimal in here? Can I have like a half a cup, a half a teaspoon? I can't have a 1.5 oxygens. That's true. But could I have a half a mole? Could I put 1.5 there? If I have a half a mole, it's basically saying I have 3.01 times 10 to the 23rd instead of 6.02, right? So if you are mathematically able to do that, put a 1.5 there. If that made no sense, we're going to follow Serena Williams' tip here, pro tip number 2. We're stuck. We're going to double our known coefficients. This will get you out of a lot of jams. What are our known coefficients? How many of you wrote that down and you have no idea what it means? What did I say at the start? Known coefficient. What are the coefficients? The big numbers, right? The ones. Good. I don't know who said that. So I'm going to double these. I'm going to double these. Now how do I look? I've got 2 Ks. I've I've got 2 CLs. Over here, I've got 2 Ks, I've got 2 CLs. I also have 6 oxygens. 2 times what gives me 6? Okay? If you get stuck, double your known coefficients. Stuck? Are you okay?
No.
Okay. The last pro tip that I want you to write down, that is LeBron. LeBron James, basketball player.
Wait, really?
Lakers.
Can you read it?
I want you to keep the polyatomic ions together, if possible. And so the last pro tip I'm going to ask you to write down. Keep the polyatomic ions together, if possible. Now that does you no good if you don't know what a polyatomic ion is. What is it? A polyatomic ion. Poly means many. So we got many atoms. Okay, which of these is a polyatomic ion? Can we pick it out?
The copper.
Good, good. The NO3. So our NO3, right, if you were to look at your ion sheet from last semester, you would see that this is the only one that has multiple elements in it. Many elements. Right? So, if I can, I want to try to keep those together. Don't worry about that. How many NO3s do I have? Remember this 2, I have 6 oxygens. I have 2 NO3s. This is where I'm saying it'll maybe save you a little bit of, I don't know, thought process if you try to keep these together. I have 2 NO3s on this side. I only have 1 NO3 on that side, so I'm going to need to double it. Multiply that by 2, now I get 2. My coppers are okay, 1 and 1. Am I done?
No.
No, it's not balanced. Silvers, good. I've got 2 AGs on this side. I've got 2 AGs on that side. Okay. Last thing, I'm going to do one more with you. I'm going to show you a little bit more of a difficult problem. It's probably the most difficult one you'll see, or type that you'll see. We want to use a little bit of a math method here. All right, so I know a lot of you shut down right away. You see math, you're like, nope, not doing it. Okay, don't do that. This math is not terribly difficult. So we're going to stick with the same thing. Follow those pro tips. We're going to leave oxygen for last. We're going to start, I'm just going to start here. This one looks the most complicated. I'm going to try to balance everything based off of that. So I've got 1 carbon. 1 carbon. Right, there's 1 there. I have 3, and then there's another one here hanging out. So I have 4 hydrogens. Over here, I only have 2 hydrogens. So I got to double that. 2 times 2 now gives me 4. Now we get to the oxygens. And I see I've got, now for my oxygen I have 2, plus 2 times 1 is 2. So I got 4 on that side. What I want to look at here now is I have my oxygens. You might say, well, I've got 3. What do I do? Double what we know, right? So I'm going to double what I know. In this case, so I'm going to double what I know. Try to get out of that jam here. 2, 4. Again, I always like to double check myself here. That becomes a 2. That becomes a 2. Instead of 4, now I've got 8. I could just double the numbers, but I want to make sure I didn't mess anything up. 4 times 2, yeah, that's 8. Okay, now my oxygens I have, I guess you might say, what do I have? 2, right? I've got 2 oxygens plus 2 times something. I'm going to put a number here. Right? That's going to be 2 times something. And that's going to be equal to, how many do I have on this side? Now I've got 8. 4 plus 4 gives me 8. So now this is why I call it the math method. We're basically looking at an algebra example here. I'm going to subtract 2 from both sides. 2x equals 6. Divide both sides by 2. My x equals 3. The math was too fast?
No, I know.
No, I get the math, I don't.
We'll get it.
Okay.
We got it.
All right, what I would like from you for tomorrow is I would like the odds or the evens. You choose. Tomorrow what we're going to do, we are going to have a little bit of a balancing equations challenge. I've got some different, you don't have to do this, but I just thought it was kind of funny. Balancing equations, this guy's balancing on too. Anyway, I'll have a couple of different slips that we could kind of practice on for tomorrow. You can just leave that, Mitchell. Good, I'll take care of it.